Well, hi, good morning. Thank you for keeping me company in my shop here. Today is November 10th, and what I want to do today is focus on the antenna situation with this radio, or more specifically, the lack of antenna with this radio. So I'm pretty sure it's supposed to have a loop antenna on a back. The back is missing. The antenna is missing too. And that removes an important element in the tuning capability of the radio, or the ability of the radio to receive. It's not just that there's no antenna, it's the antenna is actually tuned for the radio. So the antenna's not here, and what am I going to do? I've never really faced this problem head on, but I'm going to try to create something that'll work as an antenna for this radio. I'm going to try. You've been warned. Okay, let's sort out some basic stuff here. First of all, does it say anything about this loop? Does it specify anything anywhere? Here it is, loop aerial 761389, part number. So I asked the Bing AI about this. I just got a very general answer back, and it said there was nothing specific that it knows about this particular part number, and gave a general answer about loop aerials or loop antennas. Not helpful. So when you're tuning these radios, you're tuning this capacitor here. It's tuning against a coil, or in conjunction with a coil. If the antenna is missing, it can't be that coil. How can this radio work? And when I look, I see, in fact, the coil that this is tuning against is this one. See how the coil goes down to the ground or chassis, or wherever this is going, to the chassis, I believe. So if you remove the antenna, I don't think you would affect the resonance situation between this coil in here. How could that happen? Let's see. So you have this coil here. One end is tied to the chassis. The other end is going into the middle of this coil. I don't know what would happen. I mean, I have to experiment, and I can't. So another question then would be, so what exactly is the impedance of this? If I'm going to imitate this in some way, how would I even know where to start? I don't even know where to start. How would you even figure it out? For instance, I have to consider what I have available. What I have available is a whole bunch of ferrite rods here. I got 40 of them. So short ferrite rods. You could wind some wire around a piece of ferrite, and without too many turns, you'd be getting the same reactance as this coil. I don't know. I don't know. I have a couple of these antennas. We can mess around a little bit with them. Let's try that. By mess around, I don't mean hook them up and see what happens, although that's possible too. Let me get them down here. I should include this one. Not much of a loop. And this one is my last one. This one looks more like a real antenna you'd find out. Well, it's an antenna you'd find on the back of a radio. Maybe what we can do here, do not disconnect wires. Well, it's a little late for that. Maybe we can make some measurements on these and try to get an idea of what the impedance of these things are. I mean, I got 3 different coils. Let's set this one aside. Three different ones. Yeah, we'll see if we can make some measurements on those. Now, I think I stated a warning that I'm pretty clued out about all this stuff, so I may do a number of things here which are kind of stupid in the end, but that's okay. Let's see. So first thing I'm going to do is I'm going to just grab this simple loop here, a because it's just, I'm pretty sure it's just one wire looping around the way you see it. And we're going to measure its impedance. I guess maybe just leave this hanging here. It's probably the best way. We'll see what this thing says about it. So it thinks it's a, oh no, it's measured the inductance at 0.2 millihenries. 0.2 millihenries. Very interesting. 0.2. Okay, let's try this loop. It's very similar again. It's just one piece of wire, I'm pretty sure. Oh, got some company here. Yes, it's been a pretty interesting time with these two cats here. Busy, busy cats. They're busy investigating the world. Okay, it's going to do this. Okay, how about this one? And I think we'll leave it hanging in the air also. I'm worried about these coils being influenced by stuff around my bench, so we'll just leave it hanging there. What do you say? 0.2 millihenries, the same reading, a little more resistance this time. That could easily just be the way I've connected it or something. So that's 2 at 0.2 millihenries. This one's more complicated. It's got this on the outside and this on the outside. How does that work? So I'm not exactly sure. So here's an inside wire, here's an outside wire. I don't know, let's hook it up here. That's why I stopped using this coil, because I can never figure out what wire went where. We'll just do this, we'll just take a wild guess. Go on this terminal. Hang here. 0.2 millihenries again. Yeah, I just happened to pick the right yeah, 0.2 millihenries. That's interesting. Let me look around for some more stuff here. Okay, got some more stuff to mess around with, including an actual loop antenna. I'm thinking of constructing something like this for that radio. I've got lots of pieces of what I believe are ferrite rods. I really don't know, to be honest with you, what material this is, but one dot, two dots, no idea. Let's have just a bunch of random coils here. This looks like a transformer. It's just kind of small coils. Goodness knows why I have these, but I have picked up boxes of stuff along the way, and sometimes stuff like this is in those boxes. Let's see what this comes out to. It didn't even detect it as a, come on, it's got a slug inside it and everything. It didn't pick this up as a coil? Let's try it again. Zero resistance, that doesn't seem right either. Well, how do you like that? It's just not going to do this one. Huh, quite surprised. Let's just try another one. Oh, this is two coils. Coil over a coil. Let me get a simpler one, the same as the last one. I guess if one of them reads this way, the other one will too. Here we go. Same thing. Only not quite 0 ohms this time. That's a little bit disappointing. As we can assume that the reactance of this is so low, it's not even seeing it. And what else have I got? I got a whole bunch of those coils and then a whole bunch of these transformers, which I don't think are going to be useful. Look at this guy. He's got a capacitor. He's got a slug. Wow, this is a super guy here. So this connection, it's off. Okay, so it's just a coil now. To start with. I think I've messed around with this before. Okay, so we're hooked up on the coil with a big heavy slug in it. .01. Isn't that interesting? 0.01. So these big air coils, 0.2. And this thing is 1/10. Big air coils. Big air coils. I'm gonna have to remind myself about, you know, if you make the coil bigger, does the impedance go up or go down? Look at these guys. This looks like something you'd find out on a hydro pole, for crying out loud. Have I got one with the capacitor off? Yes. So this is just this big loop. What would this possibly measure at? Oh, again, it just sees it as a resistor. Okay. Oh, look at this thing. Oh, this is great. So this has to be a coil, and it feels like it's on some kind of heavy material. Look at these. What is this? Gigantic wires coming out of there. Let's hook it up. Let it hang again. And the answer is. So nothing's coming close. These small, tight coils are not coming close to the impedance of these big open coils. Here's another one here. Lovely looking coil. You can't tell the coil by its book cover. Here we go. 0.09, so we're almost halfway to the impedance that these other open coils measured with this thing. That's about it, I think. These look like solenoid coils to me. Okay. Oh yes, what about the real antenna? Now this has got wires hanging out all over the place. So these two here, they look like they might connect. Any metal there? I don't think there is. These very fine wires are, of course, very hard to deal with. I can maybe burn these. If you try to burn the insulation off, you often just melt away the conductor. So a little bit of copper sticking out on this one. Unwind the cloth covering. Not really. Well, it looks like by doing what I did, I recovered the end of it. supposed to get these wires here? Can I possibly? Okay. Okay, not sure that made a connection, but you know, don't think I want to lift these up and hang them. Let's leave it on the bench. And the answer is damaged part. I don't think I made a connection with that was a good one. Lots of wire there. No unknown or damaged part. Oh, that was cats crashing into my camera stand here. They just came flying in here at 90 miles an hour. Well, okay. I don't think we're going to get anywhere with this, but I would love to know the impedance of something like this. And I'll bet you it's written somewhere. I'm going to go looking for some more information here. Okay, so I tried the Copilot, Bing Copilot, or Microsoft Copilot earlier with this question. I'm working on an old Philco tube radio and the loop antenna is missing. The Philco part number for the antenna is 761389. What can you tell me about the antenna? I went right for the source here. And it says the Philco 761389 loop antenna is a specific part designed for a certain Philco tube radio. While detailed information about this exact part number is scarce, loop antennas and vintage radios typically serve as the primary means of receiving AM signals. That's right, this is only about the AM part of the radio. They are usually made of a coil of wire wound around a frame, which helps pick up radio waves and convert them to electric signals the radio can process. If you're looking to replace or replicate this antenna, you might consider the following options. Do-it-yourself replacement. You can create a loop antenna using wire and a suitable frame. The number of turns and size of the loop will depend upon the specific radio model and its tuning requirements. Yes, I know that. That's what I'm after. Vintage parts suppliers. Well, I'm a vintage part supplier. Philco radio forums. Well, I could go through those at some point, or other radio forums, because this problem happens with so many of these old radios. The back is gone. People didn't appreciate the antenna was critical, and it's gone with the back. And solving this in some kind of regular way would be very useful. So I asked another question. Oh, in the Ukrainian war, yeah, skip that question. What is the typical impedance of a wire loop antenna like those found on the back of an old tube radio? Okay, the typical impedance of a wire loop antenna found on old tube radios is generally quite high, around 1,000 ohms. What? 1,000 ohms. These antennas were designed to match the high impedance input of the radio's antenna circuit. So we can take a look at the circuitry for this radio and maybe make some judgments about that. If you're working on restoring an old tube radio and need to replace or replicate the loop antenna, it's important to consider this impedance to ensure proper functionality. Using a matching transform, matching transform. Just make it more complicated. Would you like, I shouldn't be so snarky, should I? It's a computer. Would you like more detailed guidance on the constructing a replacement loop antenna or finding a suitable matching? Not at the moment, but thanks for the offer. So, so what we might be interested in then says to match the high impedance. So what is the impedance of the input of this tube? Now, of course, tube impedances are basically a million until you hook up other wires and stuff to them, because it's just a wire sticking in a vacuum here. So we have a megohm to ground, so we know it's a megohm or less, and this is just a resistance here. It's as if this isn't here, so it's really not answering the question whatsoever. And the question's very complicated because look at the circuitry in here. I don't. That may. Well, it says it says what, 15 ohms, but that's probably the DC resistance, and it's given so you can ohm this out with your ohm meter and find out if it's burned out or not. That's probably why it's there. If we say this is part number 3, so look at part number 3. Broadcast aerial transformer. Nothing more said. Broadcast aerial transformer. That's interesting. I think I already figured out that the when you're listening to short wave, the signal is bypassed over to this tube. And none of this means anything at all, I guess. None of this. What's going on here? Number 5. Compensator. Shortwave aerial compensator. Okay. Because I haven't done the alignment on the radio, I haven't come across a few elements in here like this and really considered them yet. But well, other than try it and see what happens, I really don't have any direction here on how to wind up an antenna. Other than to know its impedance, it should be somewhere around 0.2 millihenries. What if I hook these loops up? Well, what if? I mean, how far wrong can it be? These couple loops I got. Well, that's something to try anyway. So while I was drinking my coffee, what suddenly struck me was, if the tuning capacitor is working against this coil, then what is tuning this antenna out here? A lot of these loop antennas have a trimmer capacitor mounted right on the radio back with the antenna. And so I'm looking for that, and there's nothing. So what is that suggesting now? Is that suggesting that this loop antenna is not so tuned? Not so critical in the tuning of things? Interesting question. Or is it just basically a bale of wire out here, and it could be almost any impedance? There would probably still be an ideal, dimensions and length of the wire and everything would be there. There's some ideal here, but maybe it's not nearly as critical because of this. And then on the short wave band, what are we tuning against now? So on the short wave band, same capacitor, same wire, same coil. I don't know the answer to that question. I don't know. Okay, so a couple more. Well, what we can try putting some loops on here and seeing how the radio behaves. How I would judge whether it's a good behavior or a bad behavior, I'm not exactly sure. Or ideal, is it anywhere near the ideal? If I hook up these different loops here, I don't know. But let's give it a try, because sometimes when you try things, you see more stuff, and more stuff becomes clear. I'm hoping. Okay, let's try a few things here. Before we deal with the radio, I have this wonderful loop antenna here. I'm not trying to promote it, but I have bought quite a few of these. And some of the radios that I've worked on have gone away with these antennas. This is just basically a tuned loop. There's the tuning. It's an inexpensive antenna. I got this off of Amazon. I'm sure you can get them in other ways. That's the jack for the 2 wires to come out from the loop antenna. But of course the wire itself is all contained inside here, so we can't really poke around with the individual loops. Oh yes we can, because I have another one here. Sad story on this one. I found that this one wouldn't tune. So when you work the tuning control, it just never seemed to tune up. So I thought, well, I'm going to take it apart. And if I ruin it, what the heck? Well, I sort of semi-ruined it here. So the tuning capacitor, I don't know where it is. This is the jack here for plugging in. This is the other loop. So now we have the two loops are exposed. One of the loops, I believe, is just a pair of wires right inside here. Now why did I think that? Because you can see it here. So you take these two wires, and if you look, you can see that they're skipping from the outside into the inside and picking up what looks like 2 turns, maybe 3 turns, right in the middle here. And then the other antenna, the wires must cross over in here somewhere. I don't know where, but there's one continuous coil all the way from here all the way to the other side with a gap for the other coil to sit. So I don't know exactly how they get the wire over. I don't see it, but that doesn't matter. So if I hook up to these wires, I'm on the multi-turn big loop, and if I hook up to these wires, I'm on the little loop in the middle. Let's just measure the impedance of this first. Okay, now, why not? What's your guess on this? It's going to be around the 0.2 again, I bet. 0.2 millihenries. So this is on the this is the big loop with, I don't know, 15 turns or something like that. So, so here it's 0.4, it's double the, that's interesting, double, okay, double the other ones, and then we're going to measure, oops, the little loop here, or the pickup loop. The idea of these antennas is that the loop with multiple turns is attached to a capacitor, and that's it. It's just a loop of wire and a capacitor, and of course they're sized properly so they have a resonance in the broadcast band. And you have a control here to turn, as I showed you on the other antenna, and you make this big loop resonate, so it's a ringing. The small loop inside can pick up some of the energy from that and deliver it to the radio. That's how these things work. So the resonant loop is very, very high Q because there's nothing attached to it. That's the idea. And you can really get that thing singing. .01 millihenries. So we've gone from double to almost nothing here. Interesting stuff. So we have this coil, which is easily connected to the radio, and we have this coil. It's also there's no question when I connected what I'm doing. This other one, there's too many questions. Let's experiment with the radio now. We'll try a couple of different loops. And what I'll do is I'll take the outdoor antenna here, okay, and we'll attach this to a loop. So it's kind of broadcasting here in my shop. The antenna signal is actually strong enough that it will re-radiate off this little loop here. I want this kind of hanging here somewhere around here, but I don't want it moving. It cannot move. It must be fixed in place absolutely, because if it moves a little bit, then all my comparative stuff will be invalid, even if it moves just a little bit. This crazy arrangement here. As long as I don't disturb it. So that'll radiate out. And now the pickup loop will also have a directionality to it. And it can be complex because we're not out here in free space. Where's free space anyway? We are in this complicated environment. Get all this stuff out of here. So maybe what we'll do is we'll do first a direct connection from the antenna, from my outdoor antenna to the radio. We'll listen to how strong it is with that. And we'll disconnect that. Good grief, I don't expect it to be as good as using the direct connection. Then we'll experiment first with the we should really use the tuned loop, the actual good one. We should experiment with this good one first and see what this can do. Or should we? Nah, you know what? Too complicated. Leave the complicated down the road, do the simple. So the simple is just hooking up these wires on the back of the radio and seeing what happens. Okay, that's good. I got an idea of what to do here. Don't know what'll happen though. Okay, let's turn on the radio here. So we're hooked up directly to the antenna. That means this radio's getting a very strong signal from the antenna, and it works really well with a strong signal, but then most radios do. It's kind of a question of what they do with the weaker signals. So, but this is to calibrate our ear and make sure the radio's operating, and also get it tuned into, I'm going to choose the French station here. So with this station hooked up this way, the radio is pretty much 100% quieted. In other words, the AVC has come on fairly strong, the sensitivity's gone down, because the signal on the antenna is quite strong. And we get a nice clear sound. No idea what he's saying. Okay, so now what we're going to do is we're going to connect up this loop antenna to start. Just the loop wires. And unfortunately, I'm going to have to use clip leads here, I think. Fairly substantial clip leads. Big, long clip leads. Probably a bad move, but we're going to start this way. Okay. Now the outdoor antenna is going nowhere at the moment. I do have that loop hanging right over here, which we will fire up in a moment. Okay, so untuned loop connected, radio tuned. And there's probably not much directionality in it. Okay, now I'm going to energize this loop from the antenna here, from the antenna connection. We'll see what happens. Just a slight improvement. Okay, so that's as good as a direct connection. I've actually turned the volume down here. So it may even be better. That's interesting. How could it be better? How could this possibly be better? Because the loop is the proper size loop, roughly. I guess you'd have to do all the alignment stuff, especially the antenna alignment, and peak it, and then find out, you know, unless it's peaked, what are you really comparing here? And there is no antenna peaking. There is no antenna peaking, Jim. That's what you figured out earlier. Okay, so now we're going to try a series of coils right in this position here. Start with this simple one. You're out. Oh my, my big black cat is showing up down here. We don't see too much of her these days. She's looking for the little ones. What's up? Oh, you want to go outside? Did you want to go in the garage? Oh, the garage? Okay, come on. We'll find out. Does she go left or right down the hall here? Hey, hey. Come on. Which way do you want to go? This way. Okay. Okay, there we go. Cat in the garage, all happy in the garage. Okay, so similar behavior. It's a, it's a coil of wire. How different can it really be? There's nothing, turn it down a little more. There's nothing quantitative about what I'm doing here. So if I want to do this one, again, how different can this be? Now remember I turned it down a bit, so signal to noise. Very similar again. Not sure I'm really proving anything. So let's try this. We'll take this antenna. I'll just hang it on this thing here. It's just hanging here in my shop. And I'm going to shut off this loop here. So now this antenna is just trying to do its thing like any antenna would. What do we get? There's a directionality to these things. I've got to just turn this. Got it dead there. Probably most favorable like that. Lots of weird stuff in this radio still, like heterodyne. By the way, the capacitor stuff I did yesterday, I haven't put that capacitor in permanently. I'm not finished with that yet. I may very well wind a coil or try a different size capacitor, because like those sounds make me think, yeah, something's not right. This thing didn't pick anything up. What's happening? Where did that come from? See, got one plate bent in here a little bit. So I'm going to grab it with my fingernail. No, I'm not. There. Bent it a little wee bit. No. Who's doing that? Well, because it clears itself, I'm going to just leave it. Well, way up here now. Another one. Okay, back to trying to tune something up. She's bad, 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 bad. Okay, I'm just going to turn on the loop here. Does that make any difference? Not very happy about that, is it? See the antenna wires touching each other there. Okay, so we're back on the loop, untuned loop here. Is that any different? Don't think so. Starting to wonder if the radio's working at all here because of the because I'm picking nothing up but heterodynes. So I think the message is you need a strong signal coming into this radio. And the loop antenna in my basement in my shop all by itself is not going to do it. Something has to be done here to make this work well. Now, what if I try to set up a tuned loop? I have a tuned loop. I have a tuned loop. Let's try a tuned loop. Okay, so we're using right now this loop here. Good morning, Kathy. So I'm going to connect this loop now. This is the connector here. I'm just going to transfer the clip leads from there to here and see what happens. Truth and recognition is a big thing in Canada. We have this process going where basically the whole country is coming to terms with what happened with the indigenous people, and it's a common thing happening in other countries around the world. And it's a tough thing to get through, for sure. Okay, we're on this antenna. This white loop is still active. I'm going to turn it off. So now it's just the loop. The loop is directional. Actually, it's got to be tuned to be really directional. Let's tune it. Wow, the tuning is not very sharp. So this antenna, I've noticed, behaves differently with different radios in terms of how sharp this is. This is not very sharp. But there it is. Just disconnect this to make sure. So this is what the radio can do with this antenna. Well, there is a sharp tuning. So that's the null direction this way. It's harder to detect the peak direction, so you detect the null direction and then go 90 degrees. Voila. It's just, this connection is crummy over here. So we go right from this position back to an untuned loop. Wrong way. What are you going to do for us, radio? One of the ways you can use this loop is like you just saw me do, where you tune this thing so it's resonating and then hold it up near another antenna. Okay, what are we finding out here? We need to compare this now to just a piece of wire and just a wire antenna. And you know what? I don't really have one. I don't, like a long wire outdoors. I don't have such an antenna. So we'll just try a chunk of wire. Some chunk of wire here, just on the floor, whatever. And just see what it does. I gotta find a chunk of wire. Okay, this is a really sad thing to try, but I'm gonna try it. This is the wire I'm gonna use. Yes, it's a cord with a plug on the end, but that's okay. It's a piece of wire. And it just runs all the way down my hall. Kinda airborne, because I just tied it to a doorknob. Here too. There we go. But I am on the ground floor. My house is unusual. The basement is only sunk a couple feet deep into the ground. I'm in it's a name for this kind of house. Can't think of it just now. So even though I'm downstairs, all the windows down here are way above ground, so they're full-size windows. The house is only a couple of feet deep into the ground. It's an unusual style. I can't think of the name of it. So consequently, the antenna is not as deep in the ground as we might think. If you think I'm in a basement. Now, we've been using loop antennas. Now I'm going to switch to just a straight wire. This is the wire connection here. Oh, that's me. Oh, there we are. Just clip it on me. Well, that's not a bad comparison, actually. I can hear the station. Okay, maybe this piece of wire is going to work. So I'm going to go on the ground part. Oh, it's about the same as me. I can't hear the station though. I'm better than a piece of wire. I think this is probably indicative of what would happen if you tried to put a real wire antenna on this radio on AM. Now, we might get some stations down here. Stronger ones are down here. The French one is kind of middle of the road, strength-wise. Yeah, we got to do something here. Just as good. I believe I knew that traffic standards would be top 10 picks. Let me try something really silly here. This radio sounds like it's trying to regenerate. Can you hear it? I don't know what to make of that. Okay, so here's what I'm going to try. Me, and then me. Just noise. Hey, I wanted to see if I'd be a good antenna link or not. Not so good. A lot of noise in there. Well, the wire antenna is going to would work better if the radio were grounded. The radio is not really grounded well right now in the sense that it's plugged into an isolation transformer. Ground is a little ways away. I could transfer the plug into a regular outlet and repeat these things, and maybe we'd be surprised. Maybe. Okay, let's try that. Let's try that. So I'm just going to unplug this. Now, this will be the first time I've got it plugged into a regular outlet, so things are a little more iffy. I haven't checked for chassis voltage and stuff like that, but I have changed the capacitors related to that. So I'm going to plug this into basically a standard outlet. Turn it on. Some of these radios get a grounding benefit from being plugged into an outlet. That's probably the best way to put it. Does that sound any different? It's working off of this now.
5 wins this year.
It's a lot different.
Because to barely play well against Minnesota State, to get smashed by Nebraska, all right, you beat Colorado State, you needed that Hail Mary to take care of Baylor. At 3-1, there were a lot of people on that. But to smash UCF the way they did,
I'm going to pull the plug out, reverse it, put it back in.
Shortly after that, they lost a close one. Kansas State team with a really good coach in Chris Klein.
Doesn't seem to make any difference.
Since then, they were down, I think they were down 7-0 to Arizona and then scored 34 unanswered.
I'm going to plug it back into the outlet here.
Beat up on Cincinnati. And then yesterday,
Hear how loud it is?
Texas Tech, and Joey McGuire thinks he's one of the more underappreciated coaches in college football. Even after a slow start, and Texas Tech coming off that big win.
Not much different, if anything.
To see what Texas Tech was able to do. After taking down
Okay, that's lots of antenna fooling. I got to stop now and think about what to do with this radio. Good. So I've been out to the grocery store and back, and while I was out driving around, I was tuning my AM radio in my car. Car radios are fantastic, and you know, comparing what I was able to pick up in the car versus what I'm able to pick up here, especially with the outdoor antenna connected directly, this guy is doing just as well as my car radio. Interestingly enough, as I pulled into my garage, of course, my car radio, I was listening to a weak AM station at that point. It went from, I could listen to it, to nothing more than that. So, you know, the noise environments in our house are terrible. And, you know, there's other problems like cats running around at your feet all the time. Do you have that in your house? Holy smokes. No, hey, that's the wire that, what are you doing? What are you doing, cat? He's chewing. Okay, if the camera goes off, it's because he's chewing the camera wire. Come on. Oh my gosh. He's too cute. Him and his brother. They're just, wow. Come on, buddy. Come on. Come on up here for, give yourself a close look. Look up, up here, up here. Hey, up here, up. Do you not know what up means? You don't know what up means? Up. Apparently he hasn't learned the word up yet. Okay, enough goofing around now. What am I going to do about this? So, you know, I can't work a miracle here, but I think what I will do is I will take this loop and I will install it inside the cabinet somehow. I don't know how. I could install it on the top, although, is that bad news doing that? Maybe it is. So anyway, that's a way forward with the antenna. So I'm not going to pursue that any further. I'm going to go back tomorrow to pursuing the unfortunate tuning situation where as you tune a station and there's a heterodyne whistle that comes with it. And maybe we'll go back to work on that capacitor. Maybe I'll try to put the coil on it. I don't know. I don't know what I'm going to try. What are you going to try, cat? What are you eating? No, don't eat those things. No, come on. No wonder the floors are cleaner. Great. Well, thanks a lot for watching today, and tomorrow I will pursue this capacitor thing. Stop chewing that. Oh my God.